Welcome to today's webinar series, Generate Testing Efficiencies by Leveraging QMT. Today's agenda, we will go through several topics. We will go through introductions, the software testing timeline specifically between the year 2000 and present. We will talk about some key metrics in software testing. We will talk about how QMT addresses these metrics and how QMT will keep up with future testing trends. I hope you will enjoy today's webinar. My name is Spencer Rubin. I have been involved in software quality assurance and testing for the past 25 years. I've worked in many different software environments, and I've watched the evolution of software testing. Today, I'm happy to share with you the benefits of Emtech's new exciting product, QMT. Who is Emtech? We are the leading provider of quality software engineering for the enterprise. And what do we deliver? In short, quality. We enable insurance carriers to shift left and achieve 100% test coverage in complex value chain testing process. We provide superior benefits through driving product quality, eliminate quality-related day two issues, and the embarrassing defect leaks associated with those product quality defects. Our product QMT features full end-to-end test coverage combined with automated test case and data generation, providing a low-code method for testing business logic and workflow. The model automates the generation of all test cases by traversing the knowledge graph model, which produces all possible permutations of the business logic. These test cases are then executed in an automation framework and the results are reported. QMT is a user-friendly and can be managed by QA team members or non-developers who understand the business flow. So let's jump into things. I'm going to discuss basic software testing timeline, let's say from the year 2000 to current. So the most common testing approach is manual testing. It is exactly what it states. It's software testing done manually. It is the oldest form of software testing and is mainly used for functional testing. Manual testing hasn't gone away. It's just been supplemented with faster or more automated and predictable testing approaches. Early manual testing used to track test cases written out by a step-by-step approach, meaning step one action and then step one expected results, following by step two, etc. This type of testing is very expensive and it takes very much time to create test cases, to review test cases for accuracy, and to execute test cases and re-execute test cases. That's all done manually. Test automation is nothing new. It's been around in one form or another for 20 plus years. Early software automation tools companies pitched it as the end of manual testing and started selling it at a very high rate. However, it didn't last. Very soon, automation users realized that there were many issues to using these tools. One in particular being that every time their application under test changed, the automation test had to change as well. This drove users of these tools to the point where the time taken for automation development and the upkeep far outweighed the benefits derived. Over the years, automation tools have become very user-friendly and flexible, however, still requires expensive skill sets, as well as heavy maintenance to reap the benefits of these tools. In 2008, test-driven design was introduced. This is a particularly interesting approach, as until this methodology, testing always occurred after development. Whereas the TDD cycle involves writing a test case for a specific requirement, then writing code to pass the test case, and then refactoring the code to improve its quality and maintainability. The big claim for TDD is its design. Tests are effectively the system design, and then we implement that design. The problem with this is we can't debug a design either. With the emergence of DevOps, CI/CD was born. CI and CD stand for continuous integration and continuous delivery, or continuous deployment. In very simple terms, CI is a modern software development practice in which incremental code changes are made frequently and reliability. The stages are source, often referred to as the version control stage, the build, where development occurs, test, deploy. Then after deployment, you start right back to the source stage in a continuous fashion. Artificial intelligence testing started in 2015. And it has increasingly become a big change in how we do software testing. Some of the ways we apply artificial intelligence to software testing are the following. Predictive analysis. Artificial intelligence and machine learning in test automation use algorithms to predict potential problem areas in software by analyzing past data. This predictive capability allows test engineers to proactively address areas vulnerable to faults, improving software quality. Another example of artificial intelligence in testing is visual validation testing, which enables comprehensive comparisons of images or screens across different browsers and devices. The system detects minor user interface discrepancies, ensuring a consistent user experience across all platforms. These are just two ways we are applying artificial intelligence to software testing. Emtech's QMT product and leveraging knowledge graphs, you have the flexibility adapting to any or all of these testing methodologies. I will dive deeper in how QMT can be applied in some of these methodologies in future webinars. So now let's shift our focus to key metrics in software testing. By using software testing metrics, we can drive efficiencies in measurable ways to drive highest quality over shortest period of time. There are many software testing metrics. However, I like to focus on three main ones. And that is testing coverage, testing effort, and testing accuracy. When we speak to testing coverage, we want to ensure that we test all combinations and values within a given system under test. Now, I mentioned before, when doing manual testing and using manual approaches, testing coverage takes a long time, whereas applying automation reduces this time. As for testing effort, we are measuring the time and cost that people are creating and executing these test cases. And of course, testing accuracy. Testing accuracy can be impacted by misrepresentation of requirements, by missing test data, and also just plain human error. One more time, QMT drives these metrics. When we speak to test coverage, QMT provides full test coverage. Manual testing can't come close. As a matter of fact, QMT will provide 30 times the amount of test coverage versus manual. Other software approaches won't map all permutations, and no one else validates the business logic. When we speak to test effort, QMT provides 80% reduction in FTE demand for QA capabilities due to increasing level of automation. And when we speak to testing accuracy, QMT features full end-to-end coverage combined with the automated test case and data generation, providing a low-code method for testing business logic and workflow. So now let's talk about industry challenges. Digitization. The need to catch up with digitization meets evolving business requirements. Or modernization. Rapid development of new products exacerbates the ability to deliver quality on time. Product launches. IT needs to meet with product launch dates on time, with fewest day two issues. Day two issues. QA is not a core competence, but must be positioned as a strategic enabler. Embarrassing errors. Failure of app dev to deliver quality products on time has an expensive opportunity cost to the business of missed applications per hour or policies per day. Embarrassing errors. Failure of app dev to deliver quality products on time has an expensive opportunity cost to the business of missed applications per hour or policies per day. And now let's go back to explore QMT. QMT's high-performance knowledge graph model-based approach enables shift left, allowing the entire QA cycle to be reduced to a few hours instead of a few weeks or months. It improved product launches. QMT discovers all defects early, delivering the level of quality needed to meet product launch dates. You have full coverage at a fraction of the cost. Using a knowledge graph model removes manual testing, human error, and extends the visibility of QA for new products to well-informed businesses analysis. It reduced quality-related day two issues. QMT enables IT executives to get more value from dollars they're already spending by testing 100% of the value chain, providing the fewest quality-related day two issues and reducing the inherent risks. You have model complex policy life cycles. By testing the end-to-end process of the life insurance systems and the integrations between them, carriers can drive quality into product launches and eliminate embarrassing errors experienced by distributors and customers post-launch. Our unique approach to quality engineering has four components. The modeler maps business logic. We have intelligent test case generation. Any change to the graph automatically updates tests, and it's a low-code solution. So a quick summary. Easy automation equals reduced FTE effort. QMT provides full test coverage. QMT also has unmatched test accuracy. QMT is simple to customize, and it doesn't take expensive resources to use this product. I hope you enjoyed today's webinar, and I look forward to our next one. Thank you.